Many organizations today are grappling with the need to update their infrastructure. The primary drivers for this modernization are the pursuit of improved efficiency and the critical need to manage rising costs. However, the path to modernization is rarely simple. IT teams often face difficult trade-offs due to complex factors like managing hybrid setups, maintaining legacy systems, and addressing the new data demands imposed by AI within the enterprise. Recent collaborative efforts between Microsoft and various storage and data platform vendors highlight strategies enterprises are using to navigate these complex issues. These examples offer valuable lessons for other companies as they formulate their own enterprise AI strategies. A significant challenge in this process is that modernization often stalls when costs begin to climb. Businesses are keen on obtaining the flexibility that cloud computing offers, yet they still rely heavily on existing systems built on virtual machines and years of ingrained internal processes. A frequent issue is that older applications were simply never architected for the cloud environment. Rewriting these applications is time-consuming and can introduce new risks. Conversely, attempting a simple lift and shift migration often results in unexpectedly high bills, especially if teams fail to modify how those workloads operate in the new environment. To counter this, some vendors are actively developing solutions that allow virtual machines to be moved to Azure without requiring immediate major changes. Early adopters of these solutions indicate that the main advantage is the ability to test cloud migration without the necessity of reworking applications on day one. For some enterprises, this initial testing phase is directly linked to the preparation of systems that will eventually support demanding enterprise AI workloads. Companies also point to the benefit of lower storage costs when these are managed through Azure's own dedicated tools, which helps maintain predictability throughout the move. The key lesson here for companies planning migration is the importance of seeking out migration paths that align with existing operations rather than forcing a complete rebuild from the very beginning. Beyond cost and complexity, data protection and strict control remain top concerns, especially within hybrid environments. The potential for data loss or extended outages causes many leaders to remain cautious about embarking on large-scale modernization plans. To mitigate these risks, organizations are increasingly focused on building stronger, more resilient recovery systems across all environments, on-premises, at the edge, and in the cloud. Standard disaster planning now comprehensively includes features such as better visibility of compromised data, robust replication capabilities, and the use of immutable snapshots. A recent integration between Microsoft Azure and several storage systems provides companies with a unified means to manage data residing both in on-premises hardware and within Azure services. This capability has generated significant interest among organizations facing strict compliance rules or local data residency requirements. These hybrid setups enable them to maintain sensitive data securely in country while simultaneously leveraging powerful Azure tools. This unified approach is increasingly crucial because successful enterprise AI applications rely heavily on data that is both reliable and well-governed. The main takeaway for businesses under similar compliance pressures is that hybrid models can effectively support compliance needs, provided the data control layer is unified. Furthermore, preparing for AI often requires establishing stronger data foundations, and this does not necessarily demand a complete infrastructure overhaul. Many enterprises want to support AI projects but are reluctant to rebuild their entire infrastructure just for this purpose. Microsoft has addressed this with SQL Server 2025, which incorporates vector database features. These features allow teams to build new AI-driven applications using their existing platform without having to switch to entirely new systems. Some enterprises enhance this approach by pairing SQL Server with high-performance storage arrays. This combination significantly improves throughput and helps reduce the overall size of AI-related datasets. These infrastructure improvements are rapidly becoming an integrated part of broader enterprise AI planning. Teams utilizing these improved setups report that the primary attraction is the ability to run early AI workloads immediately without needing to commit to an entirely new technological stack. They also note that more predictable performance helps them scale efficiently when their teams begin the critical processes of training or testing new models. The larger critical lesson here is that achieving AI readiness usually begins by improving the systems that already hold valuable business data rather than adopting a segregated or separate platform. The modernization process is also complicated by the need to manage Kubernetes environments alongside older systems, which introduces new layers of complexity. Many enterprises now operate a complex mix of both virtual machines and containers. Keeping these two environments synchronized can put a severe strain on IT teams, particularly when workloads are distributed across more than one cloud environment. To manage this, some companies are adopting unified data management tools designed to allow Kubernetes environments to function seamlessly alongside legacy applications. A clear illustration of this is the increasing utilization of Portworx in conjunction with Azure Kubernetes Service and Azure Red Hat OpenShift. Certain teams are leveraging this solution to migrate existing virtual machines into Kubernetes using KubeVirt, all while preserving their familiar workflows for automation. This strategy is designed to make capacity planning simpler and reduce wasteful over-provisioning. For many, this effort is part of a wider strategic goal to ensure their infrastructure is adequately prepared to support new enterprise AI initiatives. It also offers companies a safer, slower, and more controlled path toward full container adoption. The overarching lesson in this area is that hybrid container strategies yield the best results when they value and respect existing team skills rather than aggressively forcing dramatic operational shifts. Ultimately, a clearer path is now emerging for companies undertaking modernization. A common theme is evident across all these examples. The vast majority of enterprises are wisely avoiding attempts to rebuild everything simultaneously. Instead, they are prioritizing predictable migration plans, seeking stronger, reliable data protection mechanisms, and focusing on practical methods to support early-stage AI projects. The new tools and strategic partnerships forming around Azure strongly suggest that modernization is evolving. It is becoming less about replacing entire systems and more about strategically improving what is already operating effectively. Companies that approach modernization through small, deliberate, and steady steps, while always keeping cost containment, security, and data needs firmly in view, are more likely to move forward successfully without incurring unnecessary risk.